Hello Year 12, welcome to the first video for our fifth topic. We're looking at ratios and rates. I reckon you've seen some of this before. We're going to look at maybe some more complex examples, and hopefully we will leave this topic with a high level of confidence that we can answer these sorts of problems, even if you have done some of them before. There's some language here at the start of the notes. I reckon you probably know a bit about these things. This idea here of unitary method, don't know about that, we'll see. If we know about that or not, you will by the end. We're going to start today on ratio problems. Okay, that's our first exercise here, 201. Ratio problems. We use ratios to compare two quantities of the same type, ideally of the same units, as in meters with meters or kilograms with kilograms. Sometimes we're presented with a problem where it might be kilograms and grams, but we can convert kilograms to grams or grams to kilograms, and then we've got the same units. If I am comparing kilograms with hours, I can't convert hours to kilograms. So that's not going to be a ratio problem, that's going to be a rate problem. Ratios, written like this, with the colon here, the two dots. Yep. And I can have two terms, like this one here, or perhaps three terms, or even more. We use ratios in lots of things in everyday life. Two-stroke engines, right? The ratio of fuel to oil in a two-stroke engine, right? Like in a lawnmower or a outboard motor or something like that. We use gear ratios, perhaps when we're talking about motorbikes or bicycles. Sort of, has to do with how hard you've got to pedal to go a certain speed. Yeah. So gear ratios we deal with. We might use ratios when we're doing construction and mixing concrete, something like that. Or when we're mixing food and beverages and that sort of stuff as well. Okay, ratios pop up in a fair few places. They're fairly useful. Anyway, we're going to simplify each ratio, and what that means is each term has to be an integer, i.e. a whole number. Also, we don't want to have any units. Did I put anything with units in there? Yeah, I did. We don't want to have any units in our ratio. And our numbers, our terms, these sort of parts here, have to be relatively prime. That means there can be no factor common to all of the terms. Now, we'll step through these. First one here, 6 to 15, is pretty straightforward. The whole numbers, that's fine, there's no units, but there is something we could divide both those numbers by. We could divide them both by 3, and that would give us 2 to 5. Right. Now 2 and 5 are relatively prime. There's nothing I can divide that by, like simplifying a fraction. Right. So 2 to 5 is the simple ratio there. 10 to 25 to 100. Well, 10 and 100 could both be divided by 10, but 25 can't. Each of these numbers, though, could be divided by 5. So I think that's going to get us there. We're going to have 2 to 5 to 20. Now, there is no factor common to each of those. 5 goes into 20, and 2 goes into 20, but 2 doesn't go into 5. Or there's nothing that goes into 2 and 5. So that's it. Stop. Done. That's a simplified ratio. Next up here, 1 to 1.22. The problem is I don't have integers. We're going to get around this by multiplying, in this case, by 100. We've got 2 decimal places. So if I multiply by 100, we will have whole numbers, we'll have integers. So I can say this is equal to 100 to 122. Okay, that's pretty good. Now, I can see that, well, they're both even numbers. So we could say that's going to be equal to 50 to, what's that, 61? 61 is a prime number. And it doesn't go into 50. So that's it. Stop. Kaput. 50 to 61 is my ratio there. Right? Just a quick recap. How do we solve that? We multiplied by 100 to get rid of the decimal place. Right? If it was 1 to 1.2, I'd only need to multiply by 10. Wouldn't matter if you multiplied by 100, but I multiplied by 100 because I had 2 decimal places. Right? So I have 2 zeros on the 100. Now, D, I'm going to solve using a similar kind of approach, really. I've got fractions here. I don't want the fractions. I don't want any denominators. I need whole numbers. So what we really need to do is to multiply by the lowest common multiple of the denominators. That's a pretty complicated thing. Let's just say we're going to multiply all of the denominators together. That's 2 times 3 equals 6. 6 times 5 equals 30. Right? We're going to find the product, that means to multiply together, the product of all of the denominators. And I'm going to multiply all of the numerators, that's the top number, by that product. So remember, my number is 30. So I've got 30 over 6, 30 over 3, and now it's 30 times 2, so 60 over, well, what did I say of it? It's not a 6 there, it's a 2, right? 30 over 5. Now, I can simplify those fractions, right? So 30 divided by 2 is 15, 30 divided by 3 is 10, 60 divided by 5 is 12. Is there anything that goes into each of those? Well, 15 is 3 times 5. 10 is 2 times 5. So far we've got a common factor of 5. But 12 is 2 times 2 times 3. So there are no common factors there. 15, 10 and 12 are relatively prime. So there's our simplified ratio. One to go here, and we'll be done with our first video, hopefully in less than 7 minutes, but it doesn't happen. Anyway, 15 minutes to 2 hours. Problem, we've got units and they're not even the same units. So I'm going to say that this is equal to 15 minutes to 2 hours is how many minutes? 120 minutes. Now that we've got the same units, we'll get rid of those. 15 to 120. What can I divide both of those numbers by? In fact, I can divide them both by 15. It gives me 1, and 115 goes into 120. Well, frankly, how many lots of 15 minutes are there in 2 hours? You know, there's 15, we call it a quarter of an hour, so it's an eighth of 2 hours. It's 1 to 8. There we go. That's our ratio. No minutes or hours or anything in a ratio. A ratio has no units. Okay, that's it for ratios. What you need to do with these is to practice them. Try out all sorts of different ones. And I'll see you in class.